Combustion reactions are a special class of reactions where it's useful to have its own set of definitions and nomenclature. If you're burning something strictly for a fuel value, it doesn't make sense to use something that has a lot of commercial value. So for example, you could take something like benzene, which is a hydrocarbon, C6H6, or methanol, and you could burn these, create a flame, and generate heat for energy. But the problem is, these are all expensive materials because they have a lot of commercial value as precursors in chemical synthesis. So instead, what people will tend to do is they'll use something like coal or oil to use instead because it's a large complex mixture where any individual molecule isn't necessarily all that important. What is important is how much energy you can get out of the system when you burn it. So instead, with coal and oil, you typically only know how much carbon, hydrogen, oxygen, nitrogen, and sulfur is in the fuel. CHONS is a common form of elemental analysis. Now, the reason why combustion reactions are a subset is because it's not necessarily a well-known molecule forming into another well-known molecule, as is the case with many reactions that you may have balanced in the past. Instead, the combustion reactions are a little bit more straightforward. So instead, if we have carbon, it will react with oxygen to form CO2. In the case of incomplete combustion, you may form CO, or carbon monoxide, accidentally. The hydrogen will react to form water. The sulfur will form sulfur dioxide. And the nitrogen will just form N2, which is a stable state. So the combustion reactions are just this set of reactions here. So when you're provided a material where you don't know the exact molecular structure or molecular formula, you can use the relative abundance of these elements here to balance out the chemical reactions. Now, you may have heard that coal or a heavy oil is bad for the environment, or it makes a lot of greenhouse gases. And that conversely, natural gas, which is predominantly methane, is relatively good or clean. Now, using the combustion reactions that we saw on the previous page, it can make a lot of sense as to why. All of the carbon in the system forms CO2, whereas the hydrogen will just be used to form water. Now, this is because coal has an H to C ratio, so the relative amount of hydrogen to carbon generally less than 1, whereas methane, as we can see here, have an H to C ratio of 4. So when you burn coal, you're creating a relative large abundance of CO2 for all of the energy that you're generating, whereas for natural gas, you're creating more water out of the process as opposed to CO2. So if you're trying to reduce the greenhouse gas emissions from CO2, it's relatively better to burn methane. So one of the takeaways from this is that carbon-carbon bonds are sort of the bad ones that you have to deal with in a combustion reaction, whereas carbon-hydrogen bonds are the good ones to deal with in a combustion reaction. And this is from an energy and an environmental standpoint. But combustion reactions in general are just a subset of chemical reactions. And there's a little bit more definitions in terms of how much oxygen you need to burn the fuel that we'll talk about in another lecture.